In this video, we want to evaluate logarithms. There are 3 steps involved. Step 1, let the log be equal to x. Step 2, write the log statement in index form. And step 3, solve this equation for x. We want to evaluate log base 636. So step 1, let the log be equal to x. Step 2, write the log statement in index form. And we're going to use the scorpion tail method to rewrite log base 636 equals x in index form. So we're going to start off at the 6, which is the base, and we're going to wrap our scorpion tail around the x, past the equals, and end up at the 36. So 6 to the power of x is equal to 36. 6 to the power of x is equal to 36. So now we need to rewrite the 36 as a base of 6, and that's going to be 6 squared, because 6 by 6 is 36. Now we can see that the bases are the same on both sides of the equal, so we can cancel out the bases and equate the indices. We bring down the x, the equals, and the 2, and that's our answer. X is equal to 2. So 6 squared is 36. Okay, our next example, we want to evaluate log base 3 of 81. Step 1, let the log be equal to x. Log base 381 is equal to x. Step 2, write the log statement in index form. Again, we're going to use the scorpion tail method. Starting at the 3, we're going to wrap our scorpion tail around the x, past the equals, and end up at the 81. So 3 to the power of x is equal to 81. So 3 to the power of x is equal to 81. Now we just have to rewrite the 81 as a base of 3. So we're going to start off by changing it to 9 squared, because 9 by 9 is 81. And then we can rewrite the 9 as a base of 3. 3 squared is going to be 9. Very, very, very important that we put brackets around it. So the 9 is rewritten as 3 squared, and that is raised to the power of 2, because we actually originally had 9 squared. And when we're raising a power to a higher power, we multiply the powers. So we can cancel out the bases, bring down the x, the equals, and the 2 by 2 to give us 4. So 3 to the power of 4 is going to give us 81. Next example, evaluate log base 4 is 64. So again, we're going to let our log equal to x. We're going to rewrite our log statement in index form, and again we're going to use our scorpion tail method. So starting at the base, we wrap our scorpion tail around the x, past the equals, and end up at the 64. So 4 to the power of x is equal to 64. So 4 to the power of x is equal to 64. We're going to rewrite the 4 as a base of 2. So 2 squared, very important, we put brackets around it. And rewrite the 64 as a base of 2 as well. So 2 to the power of 6 is going to give us 64. Now we had to bring down the x here, so we have 2 squared raised to the power of x, and raising a power to a higher power, we multiply the powers. So we can see that we have our 2's matching on either side. Our bases are now matching, so we can cancel them out. So we have 2x is equal to 6, so x is equal to 3, because 6 divided by 2 is 3. Our next example, evaluate log base 6 216. Again, we let it equal to x, and then we are going to use our scorpion tail method to rewrite it in index form. So starting at the base of 6, we wrap our scorpion tail around the x, past the equals, and end up at 216. So 6 to the power of x is equal to 216. So 6 to the power of x is equal to 216. We're going to rewrite the 216 as a base of 6, so it's going to be 6 to the power of 3. We are going to cancel out the 6's now because the bases match, and equate the indices, and we just have x is equal to 3. Our next example, we want to evaluate log base 5 125. So again, we let it equal to x, and then we use our scorpion tail method to rewrite it in index form. So starting at the base 5, we wrap our tail around the x, past the equals, and end up at 125. So 5 to the power of x is equal to 125. 5 to the power of x is equal to 125. We're going to rewrite the 125 as a base of 5. It's going to give us 5 to the power of 3. Then we can cancel out our bases, cancel out the 5's, equate the indices, x is equal to 3. And then our last example, we're going to evaluate log base 9 27. Again, let it equal to x, rewrite our log in index form. Again, we start with the base of 9, we wrap around the x past the equals and end up with 27. So 9 to the power of x is equal to 27, 9 to the power of x is equal to 27. We're going to rewrite the 9 as a base of 3, and that's going to give us 3 squared. We must put brackets around it and bring down the x. And we're going to rewrite the 3 as a base of 3, 3 cubed. So now we can cancel out our bases because we have the 3's matching on either side. And we had a power raised to a higher power, so we're going to multiply the powers. 2 by x is 2x, and then we just bring down the 3. So if 2x is equal to 3, x is going to be equal to 3 divided by 2, so x is going to be equal to 3 over 2.